All right, this is the next video in our work on quadratic functions, and in this video we'll be looking at how to find quadratic functions of best fit using Desmos, a graphing calculator app, and we'll start with an introduction and then do two different examples. So a couple pieces to know is when you go to Desmos and you're trying to find a function of best fit for some data that you already have, you're going to want to plot your data in a table. So you'll add a table and you'll plot your data as x1, y1, or x2, y2, etc., x3, y3. Most important is you look at your graph. Does it look like a quadratic function? Do the points look like they're following a parabolic pattern? Okay. If they're not, don't choose a quadratic function of best fit. Choose something else. Okay. And you're going to use this form. You're going to type in an equation in this form to basically tell Desmos, hey Desmos, find a best fit equation for me. Okay, and you want the y1, x1, and x1 to match what you have set up your table as. So if you put in your data in a table where things are labeled x3, y3, you're going to want your equation to be y3 with an x3, etc. And then Desmos will give you basically the answer. Okay, so we're really just trying to learn how to use Desmos to get the answer today. So we're going to be working with two separate data tables today, and this one is going to be x1, y1. And let me scroll down to this next one, and I've actually already put these into Desmos as x2, y2. Okay. So both of these are already in Desmos, so let's head over to Desmos and work on finding a function of best fit. Okay, I'm going to pretend that we just typed in the data. And so you can see, well, first off, I can't write on the screen right now, so I can't really highlight things to point things out to you, so I'll try to just verbally describe them. But I have two data tables over on the left, and the top one is x1, y1, the bottom one is x2, y2. And we will just be working with the top one first. You want to make sure your scale is appropriate. We can't see any of the points right now, so I'll pinch and zoom a little bit, make sure we can see all our points. Looks like we do have a parabolic shape, so it does seem like a parabola would be an appropriate function to choose. So let's go ahead and set that up. So I'm going to add an expression. I'll put it right below my data table. And this is where I type in that long expression here. A x1 squared plus b x1 plus c. Okay, and so you can type in any sort of standard form of any type of function that you want, and we just are choosing a quadratic function at this point. So that's why we chose ax1 squared plus bx plus c. So it looks like the function matches the data pretty well. I'm going to copy this and bring it over to my note app so I can actually annotate it a little bit and help explain what's going on. All right, so let's take a peek at it. So I think it's clear that the curve goes through the points really, really well. In fact, it goes through every single point just about perfectly. You'll see a couple points highlighted in gray. And those are sort of special points on the parabola. Those aren't data points. One's the y-intercept and one's the vertex. So Desmos provides those for you. If we were to click on those, it would give us the coordinates. We have some information over in here. We have r squared equals 1. That's the highest r squared could be. That tells us how good of a fit we have. R squared goes from 0 to 1, and so we have a perfect fit. We have an opportunity to plot what are called the residuals. And that would just plot for each of the x values in my table how far off the curve is from the data point at that x value. And here we would just get a bunch of zeros because the curve goes exactly through all the data. But then we also down here are given what Desmos calls parameters, but what I call the coefficients in the equation. So we can write out our standard form equation. Y equals 3x squared plus 12, plus negative 4x plus 12, okay? And that would be our solution to this problem. That's the best quadratic function that matches or fits those points that we were given. All right, let's go to the next one. And we'll have a little bit of more interesting stuff going on here because I think the data won't fit the curve, or the curve won't fit the data perfectly. But let's take a look. So let's head, I've already have them in Desmos, so let's head over there. And we can delete the work we just did. We can turn on the data. Let's make sure we have all the data visible. So once again, it does look like we're dealing with a parabola here. So that tells us we probably want to be using a quadratic function of best fit. So let's type all that in as well again. So y1 and another tilde and ax1 squared plus bx1. Actually, it's x2, right? x2, y2, so I'll have to fix those. x2 plus c. And let's make those 2's instead of 1's. Because at the top of my data table, you can see that Desmos has assigned those data to be x2, y2. All right, and let us bring that back over to Desmos. I'm going to actually highlight the curve so we see some things here. All right, so we can bring that over to Desmos 2, or over to our Note app. Where are we here? So we can paste it. All right, so a couple things going on. So first off, here you see a few points in gray, and those are from left to right, the y-intercept and x-intercept, the vertex, and the second x-intercept. So again, Desmos kind of highlights those important pieces for us, so that's handy. You can see that our curve doesn't go through the data perfectly, and that's okay. That's real life, right? Real world data have some error associated with it, a little bit of scatter, and that's completely fine. And it looks like the curve does, though, do a pretty good job at matching the general trend of the data. So you can see here that we don't have a perfect fit, but we have a pretty darn good fit, right? R squared is 0.99. That's a really good match. And we are being given our parameters as well. So let's write out our final standard form function equation here. I will round to 2 decimal places. All right, there you go. So that looks like our standard form equation for that function of best fit. All right, and that's a good place to stop.